Hi everyone, and welcome back to another video on this channel. And today we're going to be going through another practice paper in preparation for the applied paper on Thursday. So I have made a couple of changes to how the videos are made based on some suggestions. So first of all, I'm now filming it in landscape because someone commented that there was a lot of wasted space. It's much easier to read if I record it this way. Secondly, I'm now uploading the papers beforehand. So if you haven't yet seen it, if you check the link in the description, there's a Google Drive link which will take you to the PDF version of this paper. So you can then have a go at it and then watch through if you need any help. Then a bit after the video goes up, I'll then upload the mark scheme and the work solutions from this video itself as a PDF as well. So you can take a look at that on the go if you're struggling to watch the video. Just wanted to say thanks a lot for the support on the videos. I hope Pure 2 was good as well. And I hope the first applied video helped. And without further ado, we can just go straight into the first question of this paper. So we've got a large data set question again, and it's now asking for the unit of measurement used for daily maximum gust and the furthest north UK weather station. So we know that daily maximum gust is in knots. So that's just something we should know. And again, we should know that the furthest north weather station is Lucas, or however you want to say it. So that's part A done. Okay, now part B. So I actually put the histogram question because someone has specially requested a couple of topics to be put into these papers. So again, before my next video, if you do have any specific topics, please feel free to let me know and I can implement them into the next paper. So they take a sample of 81 days and record the daily total sunshine. And we've been given a histogram is drawn to represent the data. And this bar, so the first bar has a width of 4 centimeters and a height of 6 centimeters. Calculate the width and the height of the bar representing the 5 to 9 class. So let's just break it down originally. So the class width, so we've got 4 centimeters, okay? However, the width is just 2. If we think about it, to go from 0 to 2, it's just 2. So width of 4 centimeters, but we can say it's just like 0 to h to 2 has 2. I'm just going to say 2, but what I mean there is that it will cover, for example, on a diagram, it would just be 2 across. For example, you're just going 2 units. So what we can say then is 2 centimeters is one unit. So 1 unit is 2 centimeters. We're doing some scaling here. And if we look at 5 to 9, so 5 less than h less than 9, that has a class width 4. So that's class width 4. I'm going to put here because this is quite poor. So class width 2. So we said that 1 unit is 2 centimeters. So a class width of 1 will be 2 centimeters. So therefore, a class width of 4, the width will be 4 times 2, which is 8 centimeters. So we know that the width of this 5 to 9 bar is going to be 8 centimeters. Now for the height, we're going to have to use some frequency density here. So between 0 and 2, we can see that the frequency is 15. So to find the frequency density, we're going to do the frequency divided by the class width, which is 7.5. Okay, so we know that the height is 7.5 units. Okay, so if it's drawn at 6 centimeters, so it says here that the height is 6 centimeters. So we can say 6 centimeters is, so 6 centimeters gives 7.5 frequency density. So I'm going to put units here because obviously in an exam you won't write that, but it's just as an explanation. You can think about it as 7.5 frequency density units. So, okay. So then if we think about one frequency density unit, we just divide it by 7.5. So we just do 6 over 7.5, which gives us 0.8. So 0.8 centimeters gives 1 frequency density unit. Okay, so now let's think, what is the frequency density of the 5 to 9 bar? So we're going to do 32 divided by 4. So for 5 to 9, frequency density is equal to 32 divided by 4 is equal to 8. So we're going to do 8 multiplied by 0.8, which will give us 6.4 centimeters. Therefore, the width is equal to 8 centimeters, and the height is equal to 6.4 centimeters. So that's a nice histogram question there. And now we can move on to part C, which is using linear interpolation to estimate the median daily total sunshine for the sample. So lots of people have different methods for this, but what I'm going to do is I'm going to use a method that I was taught, and hopefully it does make sense. So we have a sample of 81 days. So we know sample is 81 days. So the median is going to be the 40.5th value. Okay, 40.5th value. And we're going to now use linear interpolation. So the way that I was taught is if we just kind of draw a line here, okay, I'm going to draw 3 dots here. So let's look, where is the 40.5th value? So we know I'm going to write the cumulative frequency here. So let's just extend the table here for myself. So 15, 39, and then it'll be 71, and then 81. Okay, so where is the 40.5th value going to occur? It will happen in this class, the 5 to 9 class. So it will lie in here. So what am I going to do? My first step is I'm going to write 5x, or I'm going to put m here, m9. So what have I done here? I've written the endpoints of that class. So we know that the endpoints are 5 to 9. And we know that the median lies, we don't exactly know where yet, but we know that the median lies between 5 and 9. So I've labeled that here. My median is going to be m, and it's between 5 and 9. And now what we're going to do is on the bottom, we're going to be using the cumulative frequencies. So we know that before we hit this class here, our cumulative frequency is 39. So I'm going to put 39. And we know our median is our 40.5th value. And we know that the 9, what is the end? We can see here the cumulative frequency is 71. So I'm going to put 71 here. And now I'm going to be do a couple of calculations. And what I'm going to do is I'm going to say m minus 5 over 9 minus 5 is equal to 40.5 minus 39 over 71 minus 39. So you can see here that I followed a very specific way of calculating it. I have done m minus 5 on the top of my left expression. Then I've done 9 minus 5 as the denominator. And now it's important that you follow the same on your other side of the equation. So here you can see I have done 40.5 minus 39. I've gone the exact same way. Because I started with m minus 5, I did 40.5 minus 39 on the top of the right as well. And I ended with 71 minus 39, just like I did 9 minus 5 on the left. So following the exact same kind of pattern for your equation is very important. So now I can simplify this to m minus 5 over 4 is equal to 1.5 over 32. So let me now do m minus 5 is equal to 1.5 over 32 times by 4. And I'm just going to stick this into my calculator, and I get 1.5 over 32 times by 4 plus 5. And I get that my median is 5.1875. Does it give any accuracy? Yes, so giving your answer to 2 dp. So I can say that's this hours equals 5.19 hours to 2 dp. So that would be my median level of sunshine, the median daily total sunshine. And we can see here that is fine because it does lie between 5 and 9. And we do kind of expect it, so you can kind of use this as a check. We do expect it to be closer to 5. And you might be thinking, why is that? Well, let's look at the cumulative frequencies. Here we've got 15, and we've got 39 here. We know that the median is the 40.5th value. So we expect it to be very close to the start of this class, okay? Because if this one ends at 39, well, we're going to get to 40.5. So that'll be very close to the beginning of this class. So it'll be much closer to 5 than it is to 9. And that is represented in our answer because we get 5.19. Okay, so hopefully that makes sense. And now we can move on to part D. So part D is calculating the mean and the standard deviation of this data. So it's important that we remember that when we're calculating means with these classes, with these which have inequalities in it, we have to use the midpoint. Okay, so you can use your calculator for this. There's, I believe, both the graphical and the scientific calculator. You can just plug in the midpoint and it'll give you a mean. But I don't see the harm of just writing it out quickly. So I'm going to write it out. Hopefully this doesn't take too long going back and forth. I'm going to say the mean is equal to, it will be, so the midpoint of 0 to 2 is 1. So it'll be 1 times 15 plus, so I'm going to put 1, 15 plus, and I'm going to type into my calculator and then transfer it down so I don't have to keep going up and down. Then it'll be, so 1, 15 plus 3.5, 24 plus 7, 32 plus 12, 10 over to total sample of 81. So let me just transfer that down to my working out. So it's 115 plus 3.5, 24 plus 7, 32 plus 12, 10 all over 81. And that should give a mean of 5.4691. Let's see again, does it ask for a specific accuracy? It doesn't, so I always go to 3SF if it doesn't give a specific one. So 5.47 hours. Okay, next is, what is the standard deviation? Well, let's think of the formula. So the variance is the sum of x squared over n minus the sum of x over n whole squared. So our standard deviation would just be the square root of this minus sum of x over n whole squared. So we actually have this expression here because this is just the mean squared. So we have to find out what is the sum of x squared over n. Okay, and let's think here. Well, obviously we have, it should be actually, I should be writing h. So I'm going to fix that now. I'm going to go down and fix that. I should be using h here instead of x. So h is there, and I will change these letters out for h's. Yep. So now, what do we do? So we have to calculate the standard deviation. So it says we need to find sum of x squared or h squared. Okay, because we already have this expression, which is just 5.4691 squared. So now the sum of h squared, we can calculate that as, essentially, we're just going to keep the frequencies or the midpoints the same, and we are going to square the x values. Okay, so what I mean by that is we're going to square these ones here. So we're going to square the midpoints. We're going to square 1, 3.5, we're going to square 7, and we're going to square 12. But we're going to keep the frequencies the same. Okay, so let's do that now. So that will be 115 plus 3.5 squared, 24, plus 49, 32, plus 144, 10, all over 81. So we can write that as this. So now I'm going to just adjust in my calculator, and it'll be quite easy because I've kept my calculation here, and I just have to put squares, and that gives me roughly 40, or actually, can I keep it as a fraction? Yes, so that gives me roughly 3317 over 81. Okay, that is going to be my sum of h squared over n. So that means that my standard deviation is going to be the square root of 3317 over 81 minus 443 over 81 whole squared, because this is equal to 443 over 81. So now let's type this in and we should get the correct answer. 443 over 81 whole squared. And that gives us roughly 3.322 equals 3.32 hours, so 3 significant figures. So now that's the mean and standard deviation calculated. And the last thing that it's asking is estimate the number of days in the sample where the daily total sunshine was between 4 and 7 hours. So this is going to be a little bit of histogram work again. So if we think about it here, between 4 and 7, so we're clearly overlapping between two different classes here because we're going between 2 and 5 as well as 5 and 9. So we're trying to find, okay, how do we get, if we split this bar or this one here into 2 to h to 4 and then 4 less than equal to h less than equal to 5, okay, we're trying to split this up so we only calculate this one here. And then what we're going to do is we're going to add it on to, if we split this up between 5 less than equal to h less than equal to 7, 7 less than equal to h less than 9. So we're going to add that one onto this one because then that will give us 4 to 7. Okay, so let's think about this. From 2 to from less than equal to h and less than 5, so between 2 and 5, the proportion of 4 to 5, okay, is a third. So this is a third of the whole class. And you might be thinking, well, how is that? Well, let's think about it. We can split this up into 2 is less than equal to 3. Okay, so 2 is less than equal to 3. H, 2 is less than equal to h, which is less than equal to 3. 3 is less than equal to h, which is less than equal to 4. And then 4 is less than equal to h, which is less than 5. So we can split it up into 3 classes such as that. And now let's think, if we want to get between 4 and 5, that's only one of them, one of 3 options. So that's a third. Okay. And now, if there's a total of 24 days, we know that a third are between 4 and 5. So we can say that a third times by 24 is 8. So 8 days between 4 and 5. Okay, now let's do the exact same logic for between 5 and 7. So we can break this down into 5 less than equal to h less than equal to 6, 6 less than equal to h less than equal to 7, 7 less than equal to h less than equal to 8, 8 less than equal to h less than 9. So here we can see we have 4 classes now instead of 3. Well, how do we get 5 to 7? Well, we can see here that's 2 out of 4 because we can do 5 to 6, then 6 to 7. So that means it's half because we know that half of the days between 5 are between 5 and 7. What is our frequency? Our frequency is 32. So we're going to do a half multiplied by 32, which gives us 16. So 16 days between 5 and 7. So therefore, total is equal to 24 days. So that's a very long question for to start off the paper. I think that was 17 marks maybe. Don't actually know for sure. Yeah, 17 marks. And hopefully that did make sense. And now we can move on to question 2. So a bag contains X red balls and X plus 2 blue balls. And 2 balls are drawn at random from the same bag, one after the other without replacement. And the probability that both balls are the same color is 31 over 66. And we have to show a quadratic. So let's start by writing an expression for the total balls. So the total number of balls is equal to x plus 2, which is equal to 2x plus 2. Now we have to find the probability that both balls are the same color. And my idea is that we'll set it equal to 31 over 66. The probability that both balls are the same color is going to be getting a red and a red, and then adding that on to getting a blue and a blue. And that's going to be equal to 31 over 66. So let's think, what is the probability of getting 2 reds if we consider it's without replacement? So the probability of red, okay, what's the probability of just picking up 1 red? It will be, because there's X red balls, it will be X over the total, which is 2x plus 2. But we have to multiply that to the probability of getting another red. And we remember that it's without replacement. So we have to do x minus 1, because we have one less readable, over 2x plus 1, because there's one less in the total as well. So that's because there's without replacement. And we can use the same logic for 2 blue balls. We start off with x plus 2 blue balls. So it'll be x plus 2 over 2x plus 2. That's the probability of picking one ball out. The first ball is blue. Multiply that by x plus 1 over 2x plus 1, because now we have one less blue ball and one less total. So the top and the bottom both decrease by 1. So now let's add those together. x minus 1 over 2x plus 2, 2x plus 1, plus x plus 1, x plus 2 over 2x plus 1, 2x plus 2 is equal to 31 over 66. And you can see here the denominators are the same on the left-hand side. So what we're going to do is we're just going to add them, we're just going to combine it into one fraction. So x squared, and we're going to expand at the same time. So x squared minus x plus x squared plus 3x plus 2 all over. So I'm going to expand the bottom as well. 4x squared plus 2x plus 4x, which is 6x, plus 6x plus 2. And that is equal to 31 over 66. So let's now simplify the top. 2x squared plus 2x plus 2 over 4x squared plus 6x plus 2 is equal to 31 over 66. So now let's multiply by 66 and 4x squared plus 6x plus 2. So we're going to get 66 2x squared plus 2x plus 2 is equal to 31 4x squared plus 6x plus 2. So now let's expand this again. 132x squared plus 132x plus 132 is equal to 124 x squared plus 186x plus 62. So now, if we do some rearranging, we can see this will simplify quite nicely, because we're going to get 8x squared plus 54x plus 70 is equal to 0. Sorry, minus 54x. So now we can divide by 2. And we're going to get 4x squared minus 27x plus 35 is equal to 0. And I believe that is exactly what it wanted. So 4x squared minus 27x plus 35 is equal to 0. So part A show that done. And now we have to find the number of red balls in the bag. So we know that x represents the number of red balls. So let's try and solve this equation. Let's see if we can factorize this here. So I'm going to start with a 4x here and an x here. I can see that if I use a 5 here, because I'll get 4x squared minus 20x. So then I'm going to do a minus 7 here, and that perfectly factorizes that equation. So that gives me x is equal to 7 over 4, or x is equal to 5. Well, if x represents the number of red balls, x must be a positive integer. So x must be a positive integer. Therefore, x is equal to 5. So a nice probability question there with some pure implementation into there. And that means that we can now move on to question 3. So the mass of a particular species of adult fish is known to be normally distributed with a standard deviation of 40 grams. Historically, the mean mass of these fish has been 600 grams. So let's highlight this key information. And they believe that the environmental changes have caused the mean mass to decrease. They plan to take a random sample of N fish and carry out a 5% significance level. Find the minimum sample size such that a sample mean mass of 584 grams would result in a rejection of the null hypothesis. So let's start by defining our hypotheses. So we're going to say that our null hypothesis is that the mean is equal to 600, because that's what it says in the question. And the alternative hypothesis is that the mean is less than 600 because the marine biologist believes that the mean mass has decreased. And we are trying to find the fact that we're trying to show that if the mean mass is 584 grams, what is the minimum sample size going to be? So we're going to have to use some standardization here. So let's first of all define our variable. So let W be the, what does it say? The mass of the particular adult species. This adult fish species. So we can say that if we assume H0 is true, 0 is true, W, N, 600, and the standard deviation is 40. So I'm going to write 40 squared. And we know that they have taken a sample of N fish. So we can write this as mean N 600 40 squared over N. So this is now our sample mean for the adult species of the fish. And we're trying to show that the sample mean mass of 584 grams would result in the rejection of the null hypothesis. What we can do here is we can say, what is the critical, if we can find the critical region or the critical Z value, we can essentially solve and find the minimum value of N. So what I'm going to do is I'm going to standardize first of all. So we know that we're going to use the mean of 584 because that's what the question's asked us. So let us now standardize that using this equation here. So Z is equal to 584 minus 600 over 40 divided by root n. So we can now simplify this to minus 16 root n over 40. Now we're trying to find how can we make sure that 584 would be a rejection. So I'm going to use my tables, so they will give you this in the exam, and the critical Z value for 5% one-tailed test is minus 1.6449. So what do we want? We want our value to be less than this because we're trying to reject it. Okay, so we would want minus 16 root n over 40 to be less than or equal to minus 1.6449 because we're trying to reject. So what we're going to do is we're going to multiply by minus 40 over 16. So we're going to get root n is greater than or equal to 1.6449 multiplied by 40 over 16. So root n is greater than or equal to 1.6449 times 40 over 16 will give us roughly 4.11225. So n is greater than or equal to 16.9106. So the minimum, because I believe it asked for the smallest minimum sample size. So the minimum is n equals 17 because we have to pick the smallest integer. So that is part A. So this will be a question that not many of you have seen before because I'm trying to get you guys to apply your knowledge and maybe try work backwards because you never know what you could expect in these papers. Before we move to part C, I do want to clarify a few points that maybe weren't so clear earlier. So one thing I want to clarify is why did we pick this specific value for the critical value? So if you look in your tables, you'll see that for p equals 0.05, it will tell you that the critical value is z is equal to 1.6449. So because we're doing a one-tailed test, we don't have to split the significance level, obviously. So it will be 1.6449. And the way it works is we have to follow what is the sign of our alternative hypothesis. So we can see here that mu is less than 600. So there are two possibilities depending on the sign. If you have mu0 is less than mu1, so as we do, you are trying to find, you would reject if you were less than minus 1.6449. So you would reject h0 if z is less than minus 1.6449. However, if our hypothesis was that, so this is for h1, or if our hypothesis was that mu0, so I'm not sure I'm putting mu, I can just put mu, so it's greater than mu1, well then I'll reject h0 if z is greater than 1.6449. Okay, and we can see here that we are clearly working with mu is less than 600. So we're going to have to reject if z is less than minus 1.6449. And we are specifically looking for values for a rejection. So that's why I picked less than minus 1.6449. Okay, so hopefully now that clears it up, and we can now move on to part B. Sorry, I said part C, so part B. So the biologist actually takes a random sample of 30 fish, so n is equals to 30, and calculates the sample mean x, and it results in the null hypothesis being rejected. Find the range of possible values for x. So we know now that n is equal to 30, but we don't know what x bar is. Okay, but I'm going to label it, yeah, I'll keep it as x bar, even though I defined it as w. I'm going to keep it as x bar. So let's now write out x bar minus mu over the standard deviation over root n. And what we want is that again to be less than minus 1.6449. We're using the same significance level and we're still trying to reject. Okay, so we're going to say x bar minus 600 over 40 over root 30 is less than minus 1.6449. So I'm going to do this all in one go. And I'm going to say, well, x is less than minus 1.6449 multiplied by 40 over root 30 plus 600. So therefore, x bar is less than, let's write this into our calculator, minus 1.6449 multiplied by 40 over root 30 plus 600. And that gives us 587.9873. And it asks us for find the range of possible values for x. So we're going to say x bar is less than 588 to 3SF, because I always give my answer to 3SF, so I think it's best that we do it to 3SF here. So that is now part B done, and now part C. Given that the environmental changes had no actual effect on the mass of the fish, state the probability that the biologist will incorrectly conclude that the mean mass has decreased. So again, this is a nice little test of your knowledge and how well you understand these hypothesis tests. So the answer here would actually just be 0.05. And it's the exact same as the significance level. And that's actually, it's not a coincidence, and it's because you should know that the significance level is the probability of incorrectly rejecting the null hypothesis when it is true. So I'm going to give an explanation, even though you just have a given answer, because it doesn't ask for an explanation, but it will be 0.05 because the significance level is the probability of incorrectly rejecting H0, or probability of rejecting H0 when it is true. So this whole question we've been working through rejecting. Okay, you can see here we've been saying, okay, such that it would reject the null hypothesis, and it results in the null hypothesis being rejected. So we're clearly rejecting it, and it's asking us, given that there's actually no effect on the mass of the fish, so we shouldn't be rejecting because the mean hasn't changed. So therefore, we're incorrectly rejecting the null hypothesis, and the probability of that happening is the significance level, which is 5%, or 0.05. So hopefully a nice little knowledge recap there. And that is I believe that's question 3 done. And yes, so now we can move on to question 4. So a particular genetic mutation occurs in 2% of a certain population. A medical company has developed a rapid test for this mutation. If a person has the mutation, the test returns a positive result with probability 0.95. And if a person does not have the mutation, the test correctly returns a negative result with a probability of 0.9. A person is chosen at random from the population and tested. Calculate the probability that the test returns a positive result. Okay, so let's define a couple of things just so the examiner knows exactly what we're working through. So let M be the event where a person has the mutation. Okay, and I'm going to use a plus sign. So let this be the event of a positive test result. So now it's asking us, what is the probability that the test returns a positive result? Okay. So the probability of being positive, well, we can break that down. Okay, because there's only two possibilities. You either have the mutation or you don't. Okay, so we can think about it as, well, we're going to break this down into two kind of expressions. So it's the probability that you're positive and you have the mutation plus the probability that you're positive but without the mutation. Okay, so all we've done here is split the fact that a positive result into two separate events, because those are the only two events that occur. So if we add those two together, it must give us the probability of being positive. Okay, so now let's think, what is the probability of being positive and having the mutation? Okay, so if a person has the mutation, the test returns a positive result with probability 0.95. So the probability of being positive whilst having the mutation, well, the probability of having the mutation is what? 0.02, because you have a 2% chance. So it'll be 2 over 100. And then the probability of getting a positive result is 0.95. So it'll be multiplied by 95 over 100. And that will give us, let's just double check this. So 2 over 100 multiplied by 95 over 100. That gives us 19 over 1,000. 19 over 1,000. Now the probability that you're positive, but you don't have the mutation, so I'm using M complement here. Okay, well, let's see here. The probability that you don't have the mutation is going to be 1 minus 0.02. So it'll be 98 over 100. And what's the probability that you test positive? Okay, well, it will be 1 minus the probability of a negative result. So it'll be 1 minus 0.9. So you'll be tested. So you don't have the mutation. So that's 0.98. And you're testing positive. That is 10 over 100. So again, we calculate this carefully. And that gives us 49 over 500. So therefore, the probability of being positive is going to be the sum of those two, which is 0.117. So now we can move on to part B. Given that a randomly chosen person tests positive, find the probability that they actually have the genetic mutation. So we've got some conditional probability here. So the probability that they have the mutation given that they test positive. So let's write out the formula. Probability of M intersection positive over the probability of positive. So we can use part A essentially just to complete this. So we calculated m intersection positive to be 19 over 1,000. And we know the probability of being positive is 0.117, or 117 over 1,000. So we can therefore say that the probability of having the mutation given that they tested positive is 19 over 117. So I'm going to leave it as a fraction. Hopefully that makes sense to some conditional probability. And we can now work on part C. So it says here that the medical company improves the test so that it is more accurate for people who do not have the mutation. The probability that the test correctly returns a negative result for someone without the mutation is now P. So if you don't have the mutation, it will come negative with probability P. And the accuracy of people with the mutation remains unchanged. Okay? Following this improvement, the probability that a person who tests positive actually has the mutation is exactly 0.5. Find the value of P, giving your answer as a percentage to one decimal place. So now let's rewrite this information a little bit so we can kind of it's easy for us to understand. So I'm going to first of all write this out. So the probability that you test positive, the probability that you test positive, given that you have the mutation, the other way around. So you test positive, what's the probability that you have the mutation, given that you test the positive? Sorry, I keep getting confused. Yes, so that is equal to 0.5. And we're trying to find the value of P such that this is true. And we can see here that the test correctly returns a negative result with probability P. So we're going to follow a lot of the similar working as before, but all we have to do now is change this value here. So I'll highlight it in blue, change this value, because now that is P. So let's write this out now. So the probability of getting a positive result has now changed. So we're going to write the probability of getting a positive result is equal to 19 over 1,000, because that was independent of this new probability P, because it clearly says here that accuracy with the mutation remains unchanged. However, in the working here, we did 0.98 times 10 over 100. But now what we're going to do is we're going to do 98 over 100, which is the probability of not having the mutation, multiplied by 1 minus P, which is the probability of getting a positive result without having the mutation. Okay, now that is going to be 19 over 1,000 plus 98, 1 minus P over 100. So we can now write the exact same equation as we had before. It's the probability that M given, the probability you have the mutation given that you've tested positive is equal to the probability of the intersection over the probability of being positive. Well, what was the intersection between the two? That was 19 over 1,000. And now we have the new probability, which is 19 over 1,000 plus 98, 1 minus P over 100. Okay, and now we can set this equal to 19 over 1,000 is over 19 over 1,000 plus 98, 1 minus P over 100 is equal to a half. So on the left-hand side, what I'm going to do is I'm going to just multiply by 1,000. I'm going to multiply the top and the bottom by 1,000. So I get 19 over 19 plus 980, 1 minus P is equal to a half. Now let me multiply by the denominator. So I'll get 19 is equal to 19 plus 980, 1 minus P over 2. So 38 is equal to 19 plus 980 minus 980p. So now let's simplify this. So 980p is equal to 999 minus 38. So 980p is equal to 961. So P is equal to 961 over 980, which gives roughly 0.98061. And as it wants it as a percentage, that's equal to 98.1% to 1 dp, because I believe that's the accuracy that they wanted it to. Yes, to 1 dp. So hopefully that made sense. I might have got mixed a bit around with the conditional probability, but again, I think that's a good practice question, and hopefully the explanation made sense, and we can now move on to question 5. So, a technology company claims that 35% of its customers purchase an extended warranty when buying a new laptop. A random sample of 200 customers who recently bought a laptop is taken. Using a suitable approximation, find the probability that more than 80 of these customers purchase the extended warranty. So, let's first of all define X. So let X be the number of customers that purchase an extended warranty. Purchase an extended warranty. So we can model X as a binomial. So we can see here that the sample size is 200 and the probability is 0.35. And we can approximate this because we know we're going to be using a normal approximation by yn with mean and standard deviation, and variance, sorry. So find the probability that more than 80 of these customers purchase the extended warranty. So let's first start by finding the mean. So the mean is equal to NP, which is equal to 200 times by 0.35, which is equal to 70. And now the variance is NP 1 minus P, which is 70 times by 0.65, which is equal to 45.5. So we can say that our normal is now roughly, so it's 70, 45.5. And if we want to find the probability that more than 80 of these customers purchased the extended warranty, it's the probability that X is greater than 80. Well, can we say that is just the probability that Y is greater than 80? No, we can't, because we have to apply something called the continuity correction. So we have to say that this is approximately equal to the probability of Y being greater than 80.5. So now, let us use our calculator to, so this is going to be, so 80.5, and our standard deviation is root 45.5, and our mean is 70. And that gives us a probability of, so probability that Y is greater than 80.5 is equal to 0.0597 equals 0.0, sorry, let me add a couple more numbers here, so 799. And I always give my answers to 3SF. So that'll give me 0.0598 to 3SF. So just to be clear, so in the mark scheme, the calculations use the z-score. So they use the whole 80.5 minus 70, and they use they use the standardization. So they get an answer of 0.0599. However, 598 also works here. Okay, just as a clarification. So now let's move on to part B. So part B says, state with a reason why the approximation used in part A is valid. Okay, so it's valid because n is large, so we can see here n is 200. So n is large, so n is equal to 200. And p is, I believe they said 0.35, so p is close to 0.5. Okay, and p is close to 0.5. So that's all that you have to say for part B. Now part C. Find the value. So it's asking us to find the value of n, given that the variance of the approximating normal distribution is 54.6. Okay. So nothing else has really changed. We're just trying to find out the fact that now NP 1 minus P is equal to 54.6. Okay, the probability has stayed the same. They haven't mentioned anything about the probability changing. So 0.35 multiplied by 0.65 multiplied by n is equal to 54.6. So n is going to be equal to 54.6 divided by 0.35 times 0.65. So n is equal to 54.6 over 0.35 times 0.65, 240. So a nice question to finish off the stats part of this paper. And so I think this is also a nice question. A lot of questions that maybe might be unfamiliar to you. And now we can move on to mechanics. So our first mechanics question is a like velocity time graph, speed time graph. And they've given us some information here, but obviously not with the proper numbers. They've given us some letters instead. So we know that they accelerate uniformly at 0.5 meters per second squared until they reach a speed of v. They maintain the speed and deaccelerate until they come to rest. So let's sketch out this speed time graph here. So we're going to have time. So this is time in seconds. And we're going to have velocity, or I think it's, sorry, speed in meters per second. So they accelerate uniformly, I believe it says, at 0.5 meters per second squared until reaching a speed of v. So if we label this to be v, we can say it's going to be a straight line because it's uniform acceleration. Okay, they maintain this speed for t seconds. So let's say that's this long here. And then they decelerate uniformly at 1.5 meters per second squared. So this is important that this line is a little bit steeper than the initial line because they're deaccelerating quicker. So we can say that it will look something like this. Okay, so I'm going to label this t0. Actually, not from there, sorry. I'm going to label it all the way down from here and again here, because I'm going to label this t0 and t minus t0 because the distance between the two will then be, sorry, t plus t0, because then if you subtract the two, you should get t. Okay, the difference between the two is t. And it says here that they maintain that speed for t seconds. So now we know the total journey is 120. So that is part A done. We don't have to do anything else for part A. That is all we need. Part B now, it wants us to form and solve a quadratic equation in V and find the two mathematically possible values for V. So I can see here this is going to be something to do with area, okay? Because they have given us information on the area, so the total distance that they travel. So let's try and split this up into both using the information about time and also using the information about the area. Okay, let's think about the time it takes for them to accelerate until they hit the speed of v. Okay, so we can think about that as t naught. So we can say, well, t naught is going to be v over 0.5 because that's the velocity over the acceleration. Okay, so t0 is 2v. Now let's look again to get, so I'm going to label this as now t1. Okay, so t1 we can say is that how long does it take for them to decelerate? So that deceleration phase. Okay, or I'm not going to label it like that. I'm just going to say that the deceleration phase is equal to now is going to be v, because that's our velocity, over they're decelerating at 1.5 equals, so that would be 2v over 3. So this is the time taken to accelerate, and this is the time to decelerate. Okay, so what can we say about the in-between? Well, we know that 2v plus 2v over 3 plus t, okay, is going to equal 120. So t is equal to 120 minus 2v minus 2v over 3. Now let's work on using the area. So we know that the area of this first blue triangle, so this one here, to here, to here, to here, is going to be, so area of first triangle. Actually, I think it might be better if I use labels instead of this, these colors. So I'm going to label this as triangle number, shape number 1, shape number 2, shape number 3. So area of 1 is a half times t0 times the height of v. We calculated t0 to be 2v. So it will be half times by 2v times by v, which is v squared. And next, we have the area of this, this rectangle. So area of 2, well, that is just going to be t. We calculated t to be 120 minus 2v minus 2v over 3. Okay, and then multiply that by v. So 120v minus 2v squared minus 2v squared over 3. And lastly, the area of 3 is going to be a half times the deceleration phase. So the deceleration phase we calculated was 2v over 3. So half times base, and the height is v. So that will give us v squared over 3. So now, if we add all of this together, we should get that v squared plus 120v minus 2v squared minus 2v squared over 3 plus v squared over 3 is equal to 1500. So then we should get, if we do some, I'm going to simplify, so I'm going to multiply by 3 here because it'll be easier. So 3v squared plus 360v minus 6v squared minus 2v squared plus v squared equals 4500. So this gives us minus 4v squared plus 360v minus 4500 is equal to 0. So 4v squared minus 360v plus 4500 is equal to 0. And this, we can divide this by 4 to get v squared minus 90v plus 1125 is equal to 0. And I'm going to double check that I get proper solutions here. So I'm going to put this into my calculator, and I get, so let me get rid of that. So I get 1 minus 90, 1125. So v, so this factorizes to v minus 75, v minus 15 equals 0. So v is equal to 15, or v is equal to 75. Okay, so that is part B. Now for part C, so it's asking us to determine with a clear justification which value of v is the only valid solution for this journey. So we are going to use the expression for t. Okay, t equals 120 minus 2v minus 2v over 3. So t is equal to 120 minus 8v over 3. If v equals 15, t is equal to, let's try 120 minus 8 answer over 3 is equal to 80. If v equals 75, t equals minus 80. Okay. However, it's not possible to have t is not possible to have a negative time. To have negative time. So that means we can say v equals 15 meters per second is the only valid solution. And that is our first mechanics question done. And we can now move on to question number 7. So a particle P moves along the x-axis. At time t equals 0, it's at the origin, and it has a velocity of 12 meters per second in the positive x direction. And the acceleration of P at time t is equal to 4 minus 2t. So I'm going to say no, I don't have to put that. I can say acceleration is 4 minus 2t meters per second squared. Find an expression for the velocity of P at time t. So to get from acceleration to velocity, we know that velocity is the integral of acceleration with respect to time. So v is the integral of 4 minus 2t dt. So v is equal to 4t minus 2t squared over 2 plus c. Let's not forget our constant of integration. So v is equal to 4t minus t squared plus c. And it says here, at time so at t is equal to 0, the velocity is 12 meters per second. So t is equal to 0, v is equal to 12. So 12 is equal to c. So we can therefore say v is equal to minus t squared plus 4t plus 12. So that is our expression for velocity at the time t. So now for part B, it's asking us to find the time when P comes to instantaneous rest. Rest when a V is equal to 0. So t squared minus 4t minus 12 is equal to 0. Okay, and this does factorize. So let's write this out. Is equal to 0. So minus 6 plus 2. So let's shift across here. So t is equal to minus 2 or t is equal to 6. But we know, as before, time cannot be negative. Time has to be positive. As t is greater than or equal to 0, t is equal to 6 seconds. So it comes to instantaneous rest when t is equal to 6. So now, for part C, it wants us to calculate the total distance traveled by P in the first 8 seconds of its motion. It's important to understand why have they asked us part B. Why have they asked us to find the time when it comes to instantaneous rest? Okay, and that is because they're trying to guide you to the right answer. So some people might just try to take the integral between 0 and 8 of the velocity. However, we have to consider the change in direction. It's come to instantaneous rest. Okay, so we're going to have to split this integral up. So what we're going to do is we're going to calculate between 0 and 6 the velocity, the derivative velocity with respect to time, as well as we're going to add that to between 6 and 8. Okay, so, but we're going to find the magnitude of that. We're going to take the magnitudes of each of these values because that will give us the distance. Okay, so total distance is equal to the magnitude between 0 and 6 of, so the integral, so minus t squared plus 4t plus 12 with respect to time, plus the exact same thing, 6, 8 minus t squared plus 4t plus 12. So now, let's write this out. So minus t cubed over 3 plus 2t squared plus 12t between 0 and 6. And then add that on to the exact same expression, but between 6 and 8. So let's calculate that now. So if we just sub in 6, that will give us, so it's 6. I'm going to use the answer function here to help me out. So minus answer cubed over 3 plus 2 answer squared plus 12 answer. That gives me 72. And we know that if I sub in t equals 0, it will just be equal to 0. We're going to add that on now to the magnitude of, if we sub in 8, that will give us 160 over 3 minus, if we sub in 6, 72. So we're going to do 72. Sorry, hang on a second. See, that's a, it should be minus. Yes, it should be minus 72. Now, if we add this together, so 72 plus a magnitude, so the absolute value of 160 over 3 minus 72, that will give us 72 plus 56 over 3, which gives us 272 over 3 meters. So remember your units there. So that is the last part of this first of question 7. So just as a warning, so the mark scheme just shows one method, which is different to this one. I haven't got a list of all the alternative methods in the mark scheme, but hopefully this does make sense. So using this integral method and remembering to take the absolute values. And that means we can now move on. So for question 8, we can see now we've got a non-uniform rod of mass m, and it's resting horizontally in equilibrium, with one end of the rod attached to a rough vertical wall with a light and extensible string involved as well. So let's just start by drawing this diagram out. So this is our rough vertical wall, and we've got our rod horizontally in equilibrium. We know that this side here is A, this side here is B, and we're going to attach the string, and the string is at a point C. So point C, and AC is equal to 3D. So I'm going to say, well, let's say that we don't know exactly where it is, but let's say this is where the center of mass is. mg, we're going to say that this is xd, and we'll say therefore that this is 3d minus xd, because it has to add to 3d because AC is 3d, and therefore this distance here is just d, because the whole thing adds to 4d. And we know that this angle here is 60, so I know that it gives 30, but I don't want to label it too close to the diagram. I'm going to keep it a bit clear on the rod. And we know there's tension, so tension will be acting this way. And do we know anything else? Well, we have to label our reaction forces. So we know we're going to have one normal reaction force this way. So I will label this S, and I'm going to label this F. Okay, and you can think of F as the kind of the friction as well, because if we consider the string, so without the string, the rod would obviously fall down. So the friction will be going up. So the string is keeping the rod from going down. So therefore we can say, well, friction will be acting upwards. Okay, so the first question is asking us to find the exact value of x. So what we're going to do is, if we take moments about A, it means that we can completely ignore the reaction forces. So we can completely ignore F and S. And that's going to be really useful for us because it reduces the amount of working we have to do. So we're going to take moments about A. Okay, as it's in equilibrium, so we can see here that it's resting horizontally in equilibrium. So the clockwise moments are going to be equal to the anti-clockwise moments. So clockwise moments are going to be, let's see, so we're going to have mg. So the mg one, so this one here, is going to be a clockwise moment. So it will be mg xd. Our anti-clockwise moment is going to be the tension. So let's think about it. We're trying to find the perpendicular distance to A, and that will be this side over here. So how can we figure out what that side is? Well, that side is going to be cos 60. Okay, we're going to use cos 60 there. So we're going to use cos 60, t cos 60, because that gives the vertical component of the tension. Okay, t cos 60, and we're going to multiply that by the distance. So C is 3D away from A. So we're going to multiply that by 3D. So now what we can say is, we can say that the anti-clockwise moments are equal to the clockwise moments. So mg xd is equal to t cos 60 3d. So we have been given the tension is 2 over 3 mg. So I'm going to get rid of the d, and I'm going to substitute in t at the same time. So mgx equals 2 over 3 mg times cos 60 times by 3. So let's get rid of the mg's and simplify. So x equals 2 over 3 times a half times 3. So this is going to give us x equals to 1. So that's our exact value. So we know that the center of mass is exactly d away from A. Okay, so now let's move on to part B. Find the magnitude of the reaction force exerted by the wall on the rod at A, giving your answer in terms of m and g. So we did kind of look at a similar question, I believe, with connected particles in the last paper on applied. And we're going to use the same logic here. So if we think of, so this is the contact point, F here, S here. If we just imagine drawing a dotted line up here, so that would be F still, because it's the same direction. If we use Pythagoras, we can find out the length of this side here, and that would be the magnitude. So our idea is, let's find out what both F and S are, and we'll use Pythagoras theorem to find out the length of this side, which is actually the magnitude of the wall reaction. Let's take this step by step. Let's resolve vertically first. Okay, we'll resolve vertically. So if we do that, we're going to get F plus the vertical component of the tension, which is going to be T cos 60. So F plus T cos 60 is going to be equal, well, there's only one thing acting downwards, and that's mg. And well, F, we know T is 2 over 3 mg, and cos 60 is a half, equals mg. So F plus a third mg equals mg. So F is equal to 2 over 3 mg. Now let's work on finding S. So I'm going to work across here. So I think the best way to use find S is just resolving horizontally now. Okay, so if we resolve horizontally, we're going to get that S is equal to the horizontal component of T, which is T sine 60. So that means that S is equal to 2 over 3 mg times root 3 over 2. So S is equal to root 3 over 3 mg. Now we're going to use Pythagoras to find the magnitude. Okay, so we're going to say, the question is asking the magnitude of the reaction force. So we're going to say magnitude of reaction force is going to be equal to the square root of 2 over 3 mg whole squared plus root 3 over 3 mg, mg whole squared, which equals to 4 over 9 m squared g squared plus 3 over 9 m squared g squared, which is equal to 7 m squared g squared over 9 square rooted. And we can obviously simplify this to give us mg root 7 over 3. So that is going to be the magnitude of, sorry, this should be a capital M. That doesn't look right. So this is going to be the magnitude of the, what does it say specifically? The reaction force exerted by the wall on the rod at A. And we've given it in terms of M and G. So now we can move on to part C. Find the exact value of the minimum coefficient of friction between the rod and the wall needed to maintain equilibrium. So we've taken F. So F is our friction. Okay. And we calculated F is equal to 2 over 3 mg. Okay, and we know we calculated the normal reaction force to the wall is root 3 over 3 mg. So that is here. So we want FR, so we want that F equals mu S. So 2 over 3 mg equals mu root 3 over 3 mg. So we can obviously get rid of the mg's and we can get rid of the denominator. So we can multiply by multiply by 3 over mg. We're going to get 2 equals mu root 3. So mu equals 2 over root 3. So mu, I'm going to say min here, is equal to 2 root 3 over 3. So that is going to finish off our question 8. So nice non-uniform question here. And now we can move on to the final question, which is question 9. So they've given us the fact that a car of mass 1,200 kilograms is towing a trailer of mass 800 kilograms along a straight horizontal road, and it's using a light rigid tow bar. So let's draw this out. So this will be our car of mass 1,200, and it's towing a trailer of mass 800 kilograms. So 800g. and it's got a light rigid tow bar. So I'm going to draw my tensions here. There's my tensions. And the engine of the car produces a constant driving force of 3,500 newtons. And is there any other information? Well, the resistance is 600 and 400 respectively. So we've got 600 against the car. So we can say, if we shift this across, we've got 600 here, as well as T. And we've got T here. And then we've also got 400 this way. That's all the information we have. And we've got that the system accelerates from rest. Okay. So we're going to use the Newton's second law. Okay, so that's F equals ma. So Newton's second law, but we're going to use it for the whole system. Okay, so we're going to say F is equal to ma. So let's look at the total driving force is 3,500. Okay, so we're going to have 3,500 minus 600 plus 400 is equal to the mass times by the acceleration. So the total mass is going to be 2,000. So it'll be 2,000 A. So 1,200 plus 800 A. So let's simplify this. So 2,500 equals 2,000 A. So A is equal to 1.25 meters per second squared, because that's 25 over 20. So that is the acceleration of the whole system. And what we can do is we can now apply, so this is to the whole system. We can now apply this purely to the trailer, okay? Because it's asking for the tension in the tow bar. So if you apply this purely to the trailer, so Newton's second law for just the trailer, we get, so the driving force will be, so that what's pulling across is T. So T minus 400 equals 800 times 1.25, our acceleration that we just calculated. So T equals 800 times 1.25 plus 400. So the tension is equal to, 1.25 times 800 is going to give 1,000. And plus 400, that'll be 1,400 newtons. So that is the tension in the tow bar. Now, part B says, at the exact instant the speed of the system reaches 15 meters per second, the tow bar brakes. The driving force of the car and resistance of the motor remain unchanged. So what we get is, when the speed is 15 meters per second, now we have got completely rid of the tow bar. And we have to find the exact distance between the car and the trailer exactly 3 seconds after the braking of the tow bar. So now let's see if we can isolate. So we're going to draw these separately now. So we have now got, this is the trailer. We know it has a mass of 800 and it's got a resistance of 400. However, now there's no driving force for the trailer. And we're going to, if we draw the car here, it has a constant driving force of 3,500. It has a mass of 1,200 G. And it has a resistance of 600. So let me just make sure I've got everything right there. Yep, 1,200 G. And it's got resistance of 600. So that is the car. So, well, we can find out the new acceleration here because the only resistance for the trailer is 400. So if we write F equals ma, so this is again Newton's second law, we know that minus 400 is equal to 800 A. So A is equal to minus 0.5 meters per second squared. So the trailer is decelerating with 0.5 meters per second squared. So we can now calculate how much distance it travels in 3 seconds. Trailer distance in 3 seconds. We're going to use SUVAT. So we're going to use SUVAT. So we know that A is minus 0.5. We're not really, we know that T is 3. Final speed we don't know. We don't know this, but we know that U is equal to 15, and we're trying to find this because the question says it occurs. So this braking occurs when the speed hits 15. So then we can say that S equals ut plus half at squared. So S is equal to 15 times by 3 plus a half minus 0.5, 3 squared. So this is equal to, that's going to be 45 plus a half minus 0.5, 3 squared. That gives us 42.75 meters. So in 3 seconds, so after the tow bar breaks, 3 seconds after that, the trailer travels 42.75 meters. Now let's look at the car. So I'm going to draw a line down here so we can write side by side. So for the car, again, we're going to be using Newton's second law of motion. So 3,500 minus 600 is equal to 1,200A. So A is equal to 2,900 over 1,200, which is 29 over 12 meters per second squared. And now again, we can use the SUVAT. So car distance in 3 seconds is going to be SUVAT. So again, we're trying to find what the distance is. We know this is 15. We don't care about the final speed. We know that it's 29 over 12. We know that the time is 3. So S equals ut plus half at squared again. So S is equal to 15 times by 3 plus a half, 29 over 12 times by 3 squared. And that is going to give us, so 15 multiplied by 3 plus a half times by 29 over 12 times by 9. That gives us 447 over 8 meters. Okay, so if we want to find the distance between them after 3 seconds, well, what we can do is we can just subtract the distances. So we can do 447 over 8 minus 42.75, and that gives us an answer of 105, sorry, not 195. So 105 over 8 meters. I don't think it gives any accuracy. So that is the exact distance there. So 105 over 8, or you could say 13.125. But I think you should give 105 over 8 because it says exact. So that is part B done. And now the very last part for this paper is explain. I think it says, say how you've used the modeling assumption that the tow bar is light in your calculations. So the tow bar being light means we do not model its weight. So it means we assume the mass of the tow bar to be 0. The mass of the tow bar is 0. So it is not included in the total mass of the system. Okay, so something along those lines, just talking about how we don't assume that there's any weight. So obviously that's what light means. Okay, so that is the end of this paper now. I hope that this was useful. So some good difficult questions there and some suggested topics that I was asked to go through as well. My plan is I'm going to fix the mark scheme. So I'm going to just make sure that everything's perfect with the mark scheme. I'm going to then upload these work solutions alongside the mark scheme after I upload the video. So I plan to put it in the description. Hopefully it should be there by the time you reach the end of the video. And apart from that, I hope to get one more paper out, and that's going to be my predicted paper for Thursday. And any other suggestions, feedback, or if you think I made any mistakes during the paper, or if there's any mistakes on the documents I uploaded, please email me or drop a comment down below so I can get that fixed as soon as possible. If these videos are useful, please like, share, and subscribe with other people so they can use this for their revision. And this is a lot, I believe for a lot of people, this is the last paper. So all the best, you put in a lot of work, so just one last push until Thursday. And I do ask that if this has been helpful for you, for your revision, that you share it with people who are going to be going into year 13 next year, so that they could benefit from the videos that I'll be starting as well in preparation for them. So again, I hope this was useful. Any questions, please let me know, and I wish you all the best with your revision.